All right, welcome back. We are into our little glider unit that we're going to be working on. Yesterday, or in our last assignment, you watched a video on gliders. And up to this point, we've been looking at airplanes, and we've been looking at the forces that affect airplanes. And gliders are aircraft. The only thing different about a glider than a traditional aircraft is that it actually has no engine. So um, you're going to have a project where you're going to end up designing and building a wood balsa glider, kind of similar to this one right here. So you'll be given some raw materials there, and you'll be putting together a glider. So part of that is to think about some of these things that you've learned. There are some components that I'm kind of putting together here that I feel like are important and that you should focus on. And so I want to kind of go over some of this might be a review, some things we'll be hearing for the first time. Some things we'll kind of be going over like in this video. I want to talk about aspect ratio. You kind of heard a little bit about that in the last video. So um, as we go through these next couple of videos, be sure you're taking notes and kind of putting some things up here so that when we get to designing your glider, you're thinking about these things and putting them into practice so that you can build a really well-functioning glider. All right, so we're going to kind of revisit airfoils. Airfoils, we kind of had to hold on our project a little bit because Autodesk wasn't working. But we have an airfoil here, and an airfoil is just about any surface that provides an aerodynamic force, so with moving air, through interaction with moving air. So as air kind of hits our airfoil, it's creating pressure differences and it like creates lift that actually gets our plane off the ground, which is very important. Otherwise, we just have a really weird looking car. All right. So we have our airfoil. An airfoil, as we look at it, we have it like our 3D shape, but when we look at an airfoil, we just basically want to look at the side profile, the 2D view. So there's some things to look at as we go through here. So some components to our airfoil, which really weren't talked about a whole lot before, but we have the leading edge, which is at the front of the airfoil, and then on the back side we have what's called the trailing edge. Okay, and if I were to draw a line from the front edge to the trailing edge, and I drew a straight line from there to there, that would be called our chord line. It's an imaginary line that just runs from the leading edge to the trailing edge. Okay, so those are some major components that we have there. There's a few more that they're going to talk about here. We do have camber. There's an upper camber and a lower camber. So upper camber is the curved, it's the curved feature of our airfoil. This one that I'm holding here has a lot of camber to it. There's a lot more. The one on your screen that you have, it's got a little bit of curve to it. And there's curve to the top and the curve at the bottom. And there's different curvature, which is what allows for that different pressure difference. Okay, so there's ways to create extra lift on an airfoil. So we have a basic airfoil here, but this airfoil is not equipped with flaps. If I wanted to create more airfoil, I could lower the flaps, and when I lower the flaps, we're still talking about this camber. When I create flaps, you can kind of see it creates a larger camber area. So the air now has to travel over this and then down this way, whereas before it was going up there. And that extra curved part is what helps create the extra lift that we have there. So there's an increased camber on top. All right, so that increased extra gives us extra lift, and it's most noticeable at low speeds. This isn't something that's done at high speeds. This is at lower speeds when the plane is either taking off or landing. All right. Okay. The other thing that we're going to talk about is angle of attack. When you did your airfoil sim, hopefully you kind of picked up that there's some really good angles for angle of attack. When we have our airplane and it's at the runway, we're like 0, but as it starts to take off, it starts to change its attitude, and the angle of attack is like, if this was my wind going this way, that angle of attack as it comes up, that difference, that angle is what they call the angle of attack. So as we increase our angle of attack, we also increase lift, which is what you want with the plane taking off. It's going up, and as it goes in that direction, you want it increasing lift. However, you can have too sharp of an angle of attack. You're like, oh great, I'm going to go, and then you start to like, I'm going to point the nose straight up. Well, that's not good, because now your plane's kind of going this way. It's going up, but if you go too sharp, it's going to do this, and that air, like we show in our little video or in our screen that you see right here, the air begins to separate. When that separates, we have stopped creating lift, and we go into what's called a stall, and then the plane begins to fall back out of the sky. Okay. All right. So just kind of some review things. We have our relative wind, which is the direction the wind is flowing. We have our leading edge. We have our upper camber that comes over. We have our trailing edge. This imaginary line that comes through here is our chord line. This curved part at the bottom would be our lower camber, sorry. And then we have our angle of attack, which is the angle that the airfoil is to the relative wind that's coming up. Okay. All right. Now there's different platforms. A platform is like the silhouette top-down view of the aircraft. So we're looking at things. So right here, if you were looking at the top-down view of mine, we'll get into this. You can kind of see that this angles down a little bit. This goes straight. So some different views that we have. You can see right here we have elliptical and we have straight, and then like this airplane it's similar to the one that's on the screen, but this is a tapered view. I'm trying to get it on here, and I'll back up a little bit so that you can see. But you can see that the top does kind of slope down a little bit. All right. The trailing edge of my wings are straight, but the front's tapered. This is still considered tapered. All right. So that's a tapered airfoil. Then on commercial aircraft, you'll see this on jets and higher speed aircraft. They will have a swept back type of wing. And then there are even some other jets that have what they call a delta wing. So it looks like one wing combined there. It's just one big, looks like one big triangle. That's the delta wing. Okay. All right. Now, in the last video, they were talking about gliders, and they mentioned this term called aspect ratio. And gliders have a high aspect ratio. And the aspect ratio is basically the span of your wing divided by the chord width. So here's another one. So the aspect ratio would be the span, which is from wingtip to wingtip. So if you're looking at me in the little thing down there, from my finger to finger, this is the span of our wing. Okay? And then the average chord width, that is the width of our wing from trailing edge to leading edge to trailing edge. I was pointing to the wrong one. The average. So as you can tell on my wing, it's a little thinner out here. It's a little thicker. So they take the average thickness of this as we go through here, and that is the average chord width. And you divide the span by the average width of the wing, and that gives you your aspect ratio. And then, like you heard in the video, the higher that aspect ratio, the further it will glide. So then they were talking about the gliders that they were showing on that screen had an aspect ratio of anywhere of 45 to 1. meaning that if we release that plane at a mile high and we didn't catch any thermals, anything else, that plane could glide for 45 miles before it landed. Most general aviation aircraft that have an engine in them usually have an aspect ratio somewhere of around 7:1 or 9:1, meaning that if they lost power to their engine, then they have about 7 to 9 miles somewhere in there, depending on the plane, to land it. Fighter jets, their aspect ratio is much lower. So those, when they have that delta wing or swept back wing, when they lose power, they have to land pretty quickly. Okay, all right. So again, just kind of looking up here at this plane that we have on the screen. The span of this plane is 36. The average chord width is 5. So you take 36 divided by 5, and you would get a 7.2 to 1. So again, if the engine cut out while this plane was a mile high, you have about 7.5 miles to land it. Okay, so that's what that means. Okay, and then the platform, remember the silhouette, what would be the silhouette view of this particular aircraft? If you said tapered, it is tapered. Look right here, you'll see that it comes in on the sides. All right, so here we go, we have that glider, and here is the glider that they show us. This one has a span of 50 feet and an average chord width of 2. So do a little practice. Use this, take your 50 and divide it by 2 and tell me what the aspect ratio is. If you did your math correctly, hopefully you came up with 25 to 1. So if this plane was released at 1 mile high, how far would it travel? No, it's right, it would be 25 miles, okay? So again, now let's look. What is the platform of this? So take a look at those wings. Is that straight? Is it elliptical? Is it tapered? Which one do you think that is? And if you said tapered, you're correct, all right? So something else that you'll be asked to compute is your wing area. Is wing area and aspect ratio the same thing? No, they are not. The aspect ratio, you're dividing the span by the chord width. When you find the area of shapes, remember, to find the area of anything, it's length times width. So when we go to find the area of our plane here, let's go back to our original plane. We have 36 and 5. So if I take 36 times 5, what is the area of the wing? So that would be 180 square feet. So this wing covers 180 square feet. Okay? And remember, this had an aspect ratio of 7.2 to 1. So there's the square footage there. Okay? Let's look at our glider. I had a span of 50 feet and an average chord of 2. So what would be the area of this one? 50 times 2, that is 100 square feet. Now, this was 100 square feet. The plane before had 180 square feet. But this glider has an aspect ratio of 25 to 1. Even though it's got less wing area, it can glide much, I was going to say twice the distance, but it's a whole lot more than twice the distance. So it's quite a bit more, okay, like 4 times the distance just about. Okay, all right, I'm not going to go that, I'm going to stop my video there. So hopefully that kind of explains aspect ratio and kind of shows you just because you have a large wing area does not mean your glider or your plane is going to glide far. It's not concerned about wing area, it's concerned about the aspect ratio. All right? Okay, hopefully that answers a few questions that were brought up in that last video.